Can we start now? Yeah, so we can start. ICTS 2022 for International Conference on Information and Communication Technology System. So today we are doing a panel session, Cybersecurity and Infrastructure to CBSI2. Or for everyone that are joining offline, I have 170 in the Department of Informatics. Also, that are joining from Zoom online. Thank you for your joining and participation. So, my name is Bagus, and I'm going to be the moderator for this new session. So, if I see from the list here, there will be seven presented today. The first one is analysis on work exponent determination, or ASP. The second one is preemptive full avoidance technique for wireless sensor network in multiple hosting areas. The third one is optimizing scope selection in AODP-based and approach just distance technical measure.
Kita isolate itu gitu, definisi itu. Jadi di kemudian hari kalau emang kita mau extend ke use case kayak gitu, ya udah baru kita improve.
Which one will be the following data assessment management based on passive scanning CBSS? And also we will be considering whether this data based on multiple dimensional resource data. So I will think so I will give you 12 minutes and we'll do the Q&A session. Yeah, please start. Hello everyone, and from one of my students, and about the analysis on learning implementation of reverse or okay, maybe to our speakers, if you are is one of the most secure encryption out there. So let's start of analyzing the topic and the topic itself until the So we raise the power of some number times the e, and then more of our we factorize the n into these factors that is n to create acid. So if n is small enough, it is dangerous because we can only force any is fine. Next, maybe. So that's like a classic way of creating RNA. RNA, one of them is competitive method. So, and it in arithmetic calculation. Go into too much is if it comes with the what are the what are the limitations? Because in here we also know what the limit of the composite. So next. So the way to do it is we find some and we put the student has to cover this and also so next. So the way to do it is uh, and the interesting thing here is that so the arithmetic, if we collect enough messages, then we get the context without actually knowing. And this is the way to do it. And evaluate the critical analysis that is the component and the attribute. Those two are the exponent. And then we want to know of which one is successfully and for the sample itself, okay, let's use messages from only because only messages are much sensitive, right?
Next problem, we have the place inside and we have the inside.
How many characters
In field that are within. So for example, I is the cloud because always
Well, for the time, and then so next of honestly consists of two It works up to when so when the E is free, the E is getting higher, it becomes reverse. Next. We successfully implemented and next. Now we have the session. Anyone have any question about this presentation? Offline or online? Yes. Is there any question for you? Oh, yeah. Okay, please. Can you give your question?
Probably, like the previous slide. Can we go back to the previous slide? This one? Go back? Yeah. This one? Oh, once again. Yeah. Yeah, I just wondering about the covering this. And I know in state demography, we have to choose some block that probably the most optimal. We can store with pieces. We can use exit or adapt or another method to choose the base optimal blocks. In this paper or this research, is there any method that we can store SR in the image or we can pick the best block to store the text or secrets assets into big there is specific this method is not optimal with because I think when we working with exponents, it's significant aspect in as so
Okay. I can answer the first question first. Is there any specific algorithm for emptying the no, we actually implemented this image or and after the second question, I think during children
There are many specific ways that we can use this.
oh, we can use the quick analysis. Yes. So if the external value or the new value of the market quantity is much bigger, it's really difficult to use Smith or Andrew. And you have really much more powerful. Okay, so yeah, because we need to move to another presentation, so can you close it up? Okay, what we do is there is is there anyone of you that join me? Yeah, I see that there is a couple of okay, maybe I will begin, so that
Cek, cek. 1, 2, 3, cek, cek.
yeah, I can hear your voice. So can you start with that?
Screen share.
Okay.
The screen share is still disabled.
Yes, or and can you open the chat screen?
Okay.
So,
Okay, good afternoon, everyone. My name is Bagus Gede Krishna Yudhistira, and I'm here to present our research, which is called preemptive hole avoidance technique for wireless sensor network in multiple hole scenario. So for introduction, the wireless communication enable data transmission between transmitters and receivers without any physical cable. And in context of wireless sensor networks, which are low-cost network consisting of small devices, wireless communication plays a crucial role. This network possesses limited resource, but offers sensing, computing, and wireless communication capabilities. WSN find application in various fields, including traffic monitoring, emergency response, and healthcare. The primary purpose of WSN is to serve as monitoring medium, particularly in critical area where early detection of natural disaster is essential. The network must operate continuously to monitor the environment without any performance degradation. And natural disasters such as tsunami, forest fire, and landslide can be detected early when the network nodes function optimally, free from any obstacle or network holes. However, Network holes can disrupt the smooth transmission of information to the central link, which potentially delaying population evacuation in the event of disaster. And network holes typically occur when specific nodes are overloaded and selected more frequently as forwarded toward the destination node, leveraging their advantages over neighboring nodes. Furthermore, network hole can emerge due to imbalanced task allocation within the network, causing specific group of nodes exhaust their resource faster than the others, ultimately leading the whole phenomenon. From the problem identification, we can identify that how wireless sensor network can solve network hole problem where their location is unpredictable and unknown. How the wireless sensor network respond to the network hole phenomenon when at the time the message delivery process is a hole found in the specified routing area, and how the wireless sensor network decide on the new route to be selected when a node find a new hole area. Tsunami, forest fire, and landslide are examples of natural calamities that can be detected early. When the nodes in the surveillance area perform well without any obstacles or network holes, these natural events can be notified early on. A network hole will impede the seamless transfer of information to the sink, preventing the populace from being evacuated as soon as possible. The network hole is one thing that can impede the process of transmitting data from source to the destination. This research aims to solve the challenge posed by network hole in WSN by addressing network hole unpredictability or unknown location. We developed strategy for WSN to respond during message delivery when encountering network hole and determine new route to avoid whole area. This way, we can enhance the resilience and reliability of WSN, ensuring successful message delivery and overcoming the limitation posed by the network hole. The previous work, which is the same with our use case, is HARP, or Hole Avoidance Routing Protocol, which is developed by Chang et al. Generally, HARP divides its network into several hot areas to be used at a reference route at the time of delivery. The formation of this hot area is determined by the remaining energy present in the network, and packet delivery routes HARP can only run on hot area, thus limiting the package movement, making the package run as desired and avoiding the network hole during package delivery. HARP can also adopt a greedy simplified path that only used in emergency to cut the route to the and using the fastest route to the destination and selecting node the closest from the hole, but still staying in the hot area. And also coverage hole evaluating using geographic routing, or in short, geographic routing, hole avoidance, which is developed by Hamid, is hole avoidance technique that employ energy optimal point for selecting forwarder nodes. And the source node determine the optimal position for the forwarder within its transmission ring. In this mode, the network is divided by multiple layers based on the transmission range of subsequent forwarded nodes. EP, or energy point, represent the optimal energy point within the node transmission ring. It is calculated using distance between source and destination, and use broadcast hello message to form neighbor table from the network. The next forwarder node is selected based on proximity to the energy point, with the nearest node being chosen as the next forwarder. The term being used in this research is network hole, of course. A network hole refers to area of interest, which is the area that being monitored. This hole can be formed due to dynamic operation of sensor nodes. Sensor nodes might disappear due to various factors such as random speed, overheating, animal movement, vehicle, and accident. This failure occur when the static nature of the node and random distribution of sensor nodes, ROI, will refer to natural disaster. Failure in any part of the network can significantly impact the overall performance, both locally and globally. A hole in region of interest can disrupt the routing path, leading to failure in routing protocol or breakdown of the network. Areas that are not covered by sensor node are considered as network hole, where data transmission cannot be achieved. To address this issue, it is crucial to determine the location and the extent of this hole, and then employ alternative node pathway to maintain the node connectivity as much as possible. And also network lifetime, which is defined by multiple ways. Network lifetime as a sum of data aggregation until certain percentage of total sensor nodes become inactive. Data aggregation is crucial achieving energy efficiency in wireless sensor network. And the main idea behind data aggregation is optimize energy use by coordinating energy consumption across the network. And our proposed method is based on the problem before. And the researcher focus on designing the system to ensure the proper functioning of the proposed method. We have devised a hole avoidance method which enable the system operate effectively when forwarder node encounter a hole along the data path. The multi-level restricted area is our proposed method, and MRA or consists of layer that encompass the node closest to the hole. MRA is aimed to reroute the data before the area nearest to the hole and ensuring transmission from source to destination and avoiding the hole. Restricted node only utilized when strength of previous path is diminished, and MRA will allow the network to avoid region of interest area before the packet near the hole or ROI, which could hinder the packet transfer to destination. And this is in real life, this will help people to evacuate early and make people get safety as early as possible. This study introduced several terms to facilitate the discussion: source node, forwarder node, and destination node. And also restricted node, which is the node that closest to the area, closest to the whole area, and cannot be accessed. This restricted node are only used when alternative paths are being used until certain power threshold. During the initial phase, the network determines which area is the hole, and which area is restricted, and which area is source and destination. After the network deployment process, the source node send data packet to conduct a network surveying. When a data packet finds a whole area, the last node and the two nodes immediately preceding it and marked as a restricted node. The purpose of creating this restricted area is to prevent data from transmitted using previously failed route and switch to alternative route earlier. And the main process is network determine how message will be forwarded to destination, and also restricted node will broadcast a hello message to the node closest to it and the source. Restricted node will be select the two nearest node based on the distance to the restricted node and call restricted node level 2 and level 3, level 2 and level 3. Once the multi-level restricted node is formed, the forwarder node will select new route to destination. This process will continue to repeat until no more hole are be found, and the destination is determined. The hole parameter will created to determine the extent of the hole in the WSN. This procedure is performed by surrounding the hole. This is the flow chart of the initial setup phase, forwarding phase, and main process phase. From this image, we can see that from the source in this, in the initial setup, the source creating a hello message to find a hole, and after that, the nearest node from the hole is creating a level, which is the restricted node. And then the source will find a new route to destination to make sure that the data transmission is not hindered by the hole. This is the illustration of perimeter making in our hole avoidance technique. So basically, the route make a perimeter around the hole, network hole, and find a suitable path to destination. This is the illustration of the restricted node, the R1, R2, and R3. So basically, the data transmission is not utilize this restricted node. This is the route stabilized illustration. The route selection process consider average remaining energy, and if a node or a route reach specific threshold, the alternative route are established and avoid the new network hole. Network hole refer to area which are a group of nodes depleted their battery because we are using the nodes too frequently and making it into a network hole. Simulation involve
Okay, Dr. Bagus, may you speed up your presentation because your time is up.
Oh, okay.
Yeah. Okay. Maybe 1 minute left. Okay, please.
Okay, 1 minute left. Okay. From the result, we can see that at the number of node 100 to 150, without hole avoidance, they are without utilizing multi-level hole avoidance. If it can be seen that 59%, and with hole avoidance is 75%. And then from this route established result, without hole avoidance is 71 seconds, and with hole avoidance is 131 seconds because it's need a time to establish the route, so it takes a longer time. In conclusion, in summary, route selection process consider average remaining energy to avoid network hole, while alternative routes are established when specific threshold are reached. Avoiding network hole early will assure the packet can be sent to destination by using the alternative route, and could determine which area in the network being network hole. And giving people early natural disaster alarm and helping them evacuate early. And improve network performance is observed through higher packet ratio and extended network lifetime and increase average remaining energy. As network size and node count increase, the success rate of packet delivery decrease due to loss of package and network congestion. Our proposed method successfully increased the packet delivery ratio and energy efficiency in multiple hole scenario compared with network without utilizing hole avoidance technique. Okay, I think that's all for my first presentation. Thank you for your attention.
So, is there any question for all of you guys about this panel, or to participants joining online? Is there any question from you? Yes. Okay. There is no question. Okay. Dr. Bagus, may I have some question for you?
Yeah.
Okay. How about the overhead costs for this algorithm? Because you want to do the full avoidance technique, right? Have you compared it with another methods, maybe?
We compare with the previous method, but it's not really that different in the result. But there is a difference in the root established result. The earlier method, which is this one, the coverage hole alleviation, and the whole avoidance routing protocol, our established result is faster than this previous work because a lot of this method before using geographic routing algorithm and greedy, so it will be longer in terms of routing established, but these two work will sometimes find a hole and will decrease the packet delivery ratio.
Okay, thank you very much, and give applause to Dr. Bagus Kedekatan. So now we move to the next presenter. I think it's also the same author team. Dr. Bagus Kedekatan, will you present the next presentation?
Okay.
Hello, Dr. Bagus Krishna. Can you hear me?
Hello, yes.
Yeah.
I will,
Can you present another paper? So the next paper is optimizing network selection in AODP-based finance, and its approach based on distance and neighborhood evaluation. So, Dr. Bagus Krishna, I give you 10 minutes, 10 minutes, and then after that, I have 5 minutes for question and answer.
okay.
Can you present it now, please? Okay.
Okay. Our next paper is optimizing next hop selection in AODV-based FANET. In rapidly changed network topology, selecting optimal transmission link between vehicles is crucial for maintaining continuously connectivity. And we modified the original AODV protocol to improve the route selection process by incorporating parameters such as signal strength and neckbore node density. This modification involves integrating AODV protocol with prediction node trend, which enhance the selection mechanism to improve the packet delivery ratio, minimal link failure, and reduce routing overhead in dynamic topology. To enhance the effectiveness of AODV PNT, we consider calculation time, or TWR, and propose incorporating additional factor. This proposed method will facilitate a reliable and efficient communication in dynamic environment. Several terms being used in this presentation are AODV, of course, FANET, which is a technology used for inter-vehicle communication, and PNT, which is a method predicting node movement by considering several factors, such as speed, acceleration. So in selection of forward node, can choose the most optimal node to be able to continue the package to destination. And our research purposes is so that it's necessary to maintain the connection in the FANET, and when making route or route discovery, so the connection can last longer. Our DVPNT adds several factors in the choice of route, choosing the best route, expected it to be a good route, and can increase the packet delivery ratio, reduce link failure, and lower overhead routing on dynamic topology. How the addition of neckbore node stability factor can change the performance of AODV, and how AODV protocol modification performance compared to the original. This study investigate modification to the AUDV by providing optimal weight factor fraction value for different scenario. The objective to be achieved in this study are improved performance of AUDV, find the weight factor value to each parameter that being used in the calculation, such as speed, acceleration, direction, link quality, and the number of neck boring nodes. This is the improvement from AUDV, AUDV VANET, and AUDV PNT, which has its own advantages and disadvantages. Our proposed method, we called it AUDV DNA, which are modified AUDV PNT. And we adding some additional factor, which is distance between node and neighbor node, and the weight of coefficient of each factor is constant. AUDV DNA protocol utilize a route mechanism similar to AUDV. It employs a hello message to collect information about neighboring node, which is crucial for routing path decision. The TWR calculation in AUDV DNA incorporates several factors such as speed, acceleration, distance, direction, link quality, and number of neighboring nodes. This calculation process similar to that AUDV PNT, and the route request and route reply process function in the same manner as in AUDV. This is AUDV routing path, and this is AUDV DNA routing path. So it's basically the same, it's just adding some new factor such as speed, acceleration, node location, node number of neighbor, and calculate TWR such as speed, distance, acceleration, direction, link quality, and number of neighbor. Testing and simulation. Tests are being conducted by base several analytical metrics, including PDR, routing overhead, average delivery delay, and hop count with variation in vehicle speed. PDR is comparison between number of packets being sent and being received. Routing overhead is number of routing packets transmit. Average end-to-end delay is average time to take a package to get source to destination. And hop count is the number of point-to-point link in transmission line. Tests are being conducted to obtain the value of each optimal weight factor by changing the combination of each weight factor and being tested with several different scenarios, which are examined in terms of packet delivery ratio, routing overhead, average delivery delay, and hop count. By truly evaluating these metrics, we anticipate obtaining results that directly address the purpose of the study. The result of real scenario testing are the same with grid scenario test, which is performed 10 times with random mobility scenario on grid map with area 600 meter and 700 meter with the number of variation nodes 10, 30, 50, 75, and 100, with the maximum speed of each node is 15 meter per second. So the average outcome of real scenario in PDR calculation is comparing three protocol, which is AUDV, AUDV PNT, AUDV DNA. And as we can see on the table, of 5 variation of the number of nodes, the difference is minor. It's not really that much. And average end-to-end delay, when the number of nodes is 10, the delay incurred in routing with AUDV DNA is nearly identical to AUDV, with marginal difference of 0.01 second. However, compared to AUDV PNT, the delay value in DNA is higher due to computing, and the higher delay observed with 10 nodes can be attributing by selecting relay nodes, which can take longer time. Additionally, the calculation of TWR and future TWR may contribute to the increased delay. From the routing overhead, when comparing the average of RO value from AUDV PNT and AUDV DNA and the original AUDV, exhibit a lower RO value than the original AUDV. However, comparing PNT and DNA, AUDV PNT show slightly higher RO value, and AUDV PNT perform better than AUDV DNA when the number of nodes is 50 and 75. With average difference of 66 and 194 package, respectively. The highest difference when reaching 700 packet is observed at 100 nodes. This result highlight by such successfully modified from PNT to DNA, effectively reducing the generated routing overhead. And hop count. From the table 7, average hop count generated by AUDV DNA is higher than AUDV PNT. AUDV DNA has average count of 3 for each node variation, and AUDV PNT has an average count of 2.8 at each node variation. It's really a slightly higher average hop count than AUDV PNT, with average difference of 0.19. Notably, the number of hop generated by AUDV DNA is smallest when the number node is 30. In conclusion, we have successfully modified the AUDV protocol by incorporating signal strength and neighboring node density parameter, resulting improved route selection. This modification was achieved by integrating the AUDV protocol with prediction node, which enhanced the selection mechanism to enhance packet delivery ratio, minimize link failure, and reducing routing overhead in dynamic topology. Furthermore, by considering the calculation of TWR and adding several factors, we have developed AUDV DNA protocol, which can further increase the efficiency, considering factors like speed, distance, and link quality. Although AUDV DNA may exhibit a slightly higher delay than AUDV PNT, these differences are considered negligible, and the delay decreased for scenario for 30 and 50 node, but increased the number of nodes when the node reached 75. Remaining below the average delay observed in original AUDV protocol. Additionally, AUDV DNA exhibit the highest routing overhead value at 75 nodes. Overall, the AUDV DNA protocol demonstrates the improved routing efficiency while maintaining acceptable performance compared to AUDV PNT and original AUDV. Okay, I think that's all for this presentation. If there is any question.
Thank you, Dr. Bagus, for your presentation. So, is there any question from participants that joining offline or online? Is there any question? Please press your hand up. Okay, is there any question from participants that joining from online, from Zoom? Is there any question from you? Let me check for a question. So, okay, I have one question, Dr. Bagus. So,
Okay.
is there any, is there any process research, previous research that almost related to yours, or it is a pioneering works that trying to modify using the DNA and PNT Yeah.
I'm sorry, I can't really hear you due to reverb and delay.
Okay. Yeah. Okay. Now can you hear my voice?
Yeah, I can hear it.
Oh, okay. Is there any previous work that also utilize the same properties in which you want to utilize the DND and DNT? Is there any previous work that also using the same method? And how about their performance? Thank you.
From the same cases, the Audivy PNT is the newest, which is not really that good because Audivy PNT is already an old protocol, yes, and Audivy DNA is just how I will say it. It's just like improving an already good protocol. So the result is not really that significant. It's only better by 0. 0.x%. So it's not really negligible, and also adding delay to the calculation. So I think yeah, there is no comparison to Audivy PNT because it's already a good protocol to begin with, and so we just try to improve it, and the result is not really negligible, not really that much. So yeah, I think.
Thank you for answer. So give applause to Dr. Balus. Thank you thank you, Dr. Balus, and all others for your presentation. So
Okay, thank
now,
you.
yeah, we can move to another presenter. We have next paper, the fourth paper is Unmasking the Threat, Detecting Blocking Attacks in Facial Recognition. It's from Dr. Xavier Merino, Dr. Pecho, and Dr. Michael King from the Florida Institute of Technology. Can you hear my voice? Yeah.
Yes, I can hear you.
Okay.
One second, I'll start the presentation.
Yeah, you have 12 minutes for presenting, and we have 3 minutes for question and answer session. Please, Dr. Xavier.
Can you all see me and hear me?
Yeah. Okay.
All right. All right, good afternoon, everybody. My name is Javier, and I'm here to present my research on detecting cloaking attacks in facial recognition. So before we get started, I actually want to go ahead and give you something to look at. Let's see if you can guess which one of these two is the original picture. So go ahead, give it a few seconds, and let me know which one do you think is the original one and what gave it away. Let's see. Any ideas over there? Anybody? You can go ahead and send it via chat or just tell the admin. All right, so somebody's saying the original picture is picture number 1. Okay. Well, let me tell you. The original picture is actually picture number 2, or the picture on the right. The one on the left is actually the cloaked version of the picture. I'll get into what cloaking means in a few minutes. But the reality is that as people have become more and more aware of the privacy implications of sharing their pictures online, some of them are starting to use software to kind of protect their images. Now, to cloak a picture is really to add pixel level disturbances. The idea is that these disturbances are undetectable to the naked eye, and the whole purpose of this is to fool a computer into not recognizing the individual, or even wrongly identify it. In fact, the algorithm used to cloak this picture right here is called Fox, and it attempts to make this person look like somebody else to a computer. So you might be wondering, what was the motivation of this research? I mean, why do we want to spot these privacy-preserving attempts? Well, as you may already know, facial recognition is a very useful tool. It can help us in surveillance footages, in crime prevention, and even investigation. And, every day we go ahead and use face recognition even in our phones, sometimes to unlock an online bank account, other times to just simply access our phones. However, that doesn't mean that facial recognition is without any challenges. In fact, aside from the privacy concerns, instances of false positives or even false negative identifications can have and actually have led to serious consequences, such as wrongful arrests and even legal implications. At the moment, right now, there are several such cases going on in the United States, where false positives have led to people being wrongfully arrested. As such, it is really not surprising that a lot of people are trying to protect their identities. And they do so by using algorithms such as the one that I talked about and the one that was used for that picture that I showed you before, Fox. The thing is, by using these cloaking algorithms, they're actually increasing the false negative and false positive rate of an algorithm. In other words, they may be putting other people at risk. But furthermore, if you are the one creating the algorithm, let's say that you are the model trainer, and you're attempting to train your facial recognition algorithm for some service, you're now facing the potential degradation of your model's performance. And given that updating and retraining models is very costly, and today it's estimated to cost between 3 and 30 million US dollars, well, this kind of problems can actually be very costly, not only for your performance, but for your wallet. Our research attempts to detect this kind of poisoning attacks created with specifically Fox. The reason why we chose Fox is because it was the most popular cloaking tool to date. And we do this in order to extend the life of the models and to prevent performance degradation. The idea is, if we can keep these pictures out of the training data sets, we will essentially be able to improve our accuracy. Now, other alternatives have been proposed in the literature. Some of them, for example, like Oriol, assume that you can go ahead and you can create a cloaked version of every single picture that you have in your data set and then train on that. We find this is a little bit hard to do given that the training data sets are already quite big. And in order to do this, you would have to create even more pictures. However, this might be necessary in order to acquire some robustness against Fox, for example. Other approaches involved attempts to classify images based on patches of a picture, seeing which patch is more impacted by the disturbances in the pictures. And so by trying to do so, you could say, okay, this picture is 80% chance that it's cloaked or not. Unfortunately, this kind of things haven't really worked really well in the wild, so it hasn't been proven. Other people simply, say newer models will do better, so let's just adopt newer models when they come out. And while that is true, newer models might not be released very frequently, and even producing them might be actually very costly, especially if you're a company and you're providing a service. So other people just simply provide a simple solution. Let's just use anthropomorphic points. That means the points in the face that make a face unique. For example, the distance between your eyes or the distance in your nose. And while that is good, that used to be classical facial recognition, today, most models use deep learning approaches, so we can't really make use of those. Our approach, which is distinct from all of these, is actually inspired by a claim made in the original Fox paper. Mainly that, given a sufficient number of identities, the Fox algorithm should be immune to anomaly detection techniques. So let me go ahead and show you how our approach works. Our approach starts with simply obtaining a picture to analyze. We turn that picture into an error level analysis counterpart. Now, error level analysis, or ELA for short, is an image forensic technique, and it's typically used to detect modifications, enhancements, or any sort of alteration in a picture. And it does so by compressing the image into different levels and then analyzing the disturbances on each level. Let me show you how that looks. For this research, we used the PubFig 83 dataset, and that's because Fox used that one as a test set, and it reported around 99% of cloaking success. Now, this dataset consists of 83 identities with 100 pictures per identity for a total of 8,300 images. Now, we create cloaked versions of each image for each predefined level in fogs. So fogs allow us to create low, middle, and high perturbation modes or cloaking modes. And as you can see here, as the cloaking level increases, the perturbation in the image becomes a little bit more apparent. In total, since we did this for the entire data set, we generated around 33,000 images. In this sample identity, you can see that this is the original, the low, the middle, and the high, and below they are the ELI counterparts. If you examine the ELI in the first picture, you may recognize that there is noise, but the noise is well scattered around the picture. While as the fog's cloaking algorithm is applied, you can notice and you can even start discerning a little bit of the faces in here, which means that the noise actually got more concentrated in the face area when compared to the rest of the image. So now that we have these ELI images, what we can do is we can go ahead and extract the features from those pictures. And in our research, we use image2vec with a ResNet 18 backbone. We did so to extract the features. And we chose this one because it was a very fast pre-trained model. After that, we end up with a feature vector of around 512 dimensions that characterizes that ELI image, which we then use to go ahead and reduce because it's quite big. So we reduce it into 3 dimensions using PCA. We did this for 2 purposes. 1, to increase the visibility of the data so that we can actually visualize how it looks like. And 2, to reduce the time it would need to train. So if you go ahead and visualize the principal components using just 2 out of the 3, you can start seeing that the green is, by the way, original, and the red is the cloaked images. You can see that in low, they're a little bit more intertwined, but as you go to mid and high levels, you actually start seeing more level of separation between them. We're going to exploit this to see if we can classify them. So based on those feature vectors, we can now feed them to a classifier. And we're going to be using here k-fold cross-validation on support vector machines using 5 folds. We use this because k-fold validation essentially splits the data on folds or subsets, and we can train on, let's say, 4 subsets and test on the remaining one. And we repeat this process with variations of the test and training sets. This allows us to help lessen the impact of the random fluctuations found in the data. So let me talk a little bit more about the results that we obtained using this. When faced with pictures that were in the low cloak levels, our accuracy was around 93% in being able to detect them, which was kind of good. But it actually increases quite a bit when we go to the mid and high cloaking levels. So in the mid and high cloaking levels, they're both over 99%. If you go ahead and we go back for a second, and we take a look at the pictures, you can clearly see that the perturbations here are more noticeable in the pictures. In fact, other researchers have pointed out that the perturbations in the mid and high levels introduce creases, wrinkles, and even discolorations in people's faces, which is no surprise as to why the ELA version could actually find more and more of these details, becoming easier to identify. If we were to visualize these results, we'll see that in the low version, for example, the low cloaking version, we're around 93% of accuracy, while in the mid and high levels, we reach over 99%. However, this is not very representative of the real world. In the real world, users, when they submit pictures, let's say to Facebook or Instagram or any other social network, they don't really go ahead and do something low, middle, and high, and they tell you. Rather, they may submit absolutely anything. And so in a mixed cloaking model, we actually reach around 97% accuracy. What I mean by a mixed cloaking model is our test set was clearly just a random collection of pictures distributed between low, middle, and high cloaking levels. And so we let the algorithm just see a random one and just see whether it was cloaked or not. And we were able to actually accurately predict whether it was cloaked or not in around 97% of the cases. So in conclusion, what we present here is a way of reliably detect cloaking of images. Even when, as a claim was made by the original authors, having enough number of identities, over 30 they say, provides immunity against this type of techniques. So we were able to overcome that barrier and provide reliable detection of those cloaked images with varying levels of cloaks between low, middle, and high. We did this with the goal of helping models to live a little longer. The idea is that if we can help avoid models being poisoned, slowly poisoned over time by this data that has been introduced, then we can get the images out of the training set, ensure lower false positives and false negative rates, and of course, extend the lifetime of the model itself. All right, well, that's about it. Any other questions?
Thank you, Dr. Javier, for your presentation. It's a very good and impressive presentation. And is there any one of you have question for Dr. Javier about this research? Any question, please? Okay, is there any one of you that joining online want to ask some question to Dr. Javier? Okay, if not, then may I have a question, Dr. Javier?
Sure, go ahead.
Yeah, okay. Yeah, I see that there is a different result of precision, especially for low clock image compared to the high clock image. And because sometimes there is some algorithm have a good condition and best condition and worst condition of image. Is that happen to your algorithm? Is there any original image that your proposed method cannot work well? I mean, there's too much noise or others, or is there any image characteristic in which your algorithm may perform worse or perform best? Can you provide your answer to this? Thank you.
Sure. Yes, actually, I have explored something like that already. And if you take a look at the first image that I showed you here, it's a very high resolution image, so you couldn't really tell. If you go ahead and take a look at these images, they're lower resolution, so it's more clearly visible.
Yes.
However, one of the limitations as currently implemented is that our ELA method will actually take a look at the entire image.
Okay.
So that being said, if you take a look at the entire image, you're going to find more black spots rather than the concentration of noise. However, a quick fix for this would be to simply detect phase regions, which you're still able to do, which isn't actually an extension to our research currently undergoing. Just extract the phase region and apply the ELA to that phase region, and will actually combat that limitation that we're currently posing. So in this image, for example, it will be harder to tell if it's been altered just because the ELA and the feature extraction happens on the entire image rather than just on the phase region. So having a bigger area that has suffered no modification will actually confuse the classifying algorithm. But by focusing just on the region, on the facial region, then you're actually able to defeat that limitation. So yeah, excellent question.
Okay, thank you. Thank you very much for your answer. So yeah, you may focus on your on the facial recognition, right? And in the next research, you may also detect the face so that high resolution image will they may have.
Correct.
Okay. Thank you for your presentation, Dr. Javier. Please give applause to Dr. Javier.
Thank you very much.
Thank you very much for your participation, Dr. Javier. So now we will go to the next presenter. We will going to have a systematic literature review of genetic algorithm-based approach for task scheduling. It will be presented by Dr. Hening Tijiptani, Dr. Ari Mazharuddin, and Dr. Diana Purwitasari. Dr. Hening, are you ready? Also, please, you don't need to use the phone actually because we will start the presentation from Dr. Hening, and your presentation time is 12 minutes, so maybe you can use that microphone so that people joining online may also clearly hear your voice. Please, 12 minutes.
Thank you very much. Good afternoon. This one is my paper titled A Systematic Literature Review of Genetic Algorithm-Based Approach for Whole Task Scheduling. So our topic is genetic algorithm-based for whole task scheduling. Next. Why do I create this paper? Because cloud task scheduling on environment is poses significant optimization challenge. So it involves fulfilling multiple objective functions. So it has to reach more than one objective, and then the meta-heuristic algorithm can discover near optimal solutions to solve it. Evolutionary algorithms is one of the heuristic algorithms. It mimics the natural evolution, and the famous or wide-known algorithm in here is the genetic algorithm. The GA should go for a wide range of optimization issues. So we implement lot of researchers implement the genetic algorithm for the problem for fast scheduling. Okay, next. How do we create the systematic literature review? We have a population here, so the population is a paper containing clock, computing, and task scheduling. The intervention is the algorithm should use genetic algorithm, whether it's hybrid or modification. And then we compare this one, we compare parameter, function objective, dataset, and then the simulation or experimental tools comparison. The outcome is cloud-based scheduling performance enhancement based on function objective and the improvement. And then our context is cloud task scheduling can be performed either on simulator, so using simulation, and or on the actual platform. Next. This is our research questions and motivation. Why do we create the paper systematic literature review? The first research question is what are the latest advancements in genetic algorithm-based algorithm for cloud task scheduling? Our motivation is to gather and evaluate genetic algorithm methods in various cloud computing situations. And the second research question is how can we enhance the GA by adjusting parameters according to the context in which algorithms are applied? And our motivation to use these research questions is to assist in evaluating the performance enhancement of various function objectives by examining GA parameter modification. And the third one is how can we integrate, so hybrid, right? Genetic algorithm with different task scheduling methods. Our motivation is to assist in evaluating the hybridization of GA with other techniques and determining the efficiency of function objectives. We search the journal and papers from these two electronic data sources and we will emphasize there. Why do we use this? Because ICTS is use this one. We have a full access of these two electronic data source. And we use the search term, so we have the three terms of search term using the population, workflow, task, plot, and scheduling. Our next intervention is using genetic algorithm. The keyword, the next keyword is genetic algorithm or PA. So the keyword is using P1 or P2, etc. And then the search string is this one. So on the IEEE Explore or Science there, we input the research. And after we input the research, next. Okay, we have also the inclusion and exclusion criteria. Remember, we use the conference and also the journal. For the journal, we use the studies 2019 until 2023. For the conference, we use the study from 2021, so the latest one, until 2023. We also use the peer-reviewed journal and conference. Article is written in English, so no Indonesian journal or conference article here. And then for the fifth one, the article generates validated outcomes. If the outcomes is ambiguous or I don't understand what this means, so we reject it. And the last one, we use the scheduling based on genetic algorithm techniques. The right one is exclusion criteria. We exclude the paper which is not presented in pertinent journals or conference. And for the conference article, at least 7 conferences have been organized by this reputable conference organizer. For example, ICTS, because ICTS is more than 7, what's 14, right?
Yeah.
14 ICTS. So we include this one. If the conference is the first one or the second one or the third one, we eliminate it. And then the third, we exclusion criteria is we exclude the survey, review, and short report. So we only include the original or the research paper. And then the fourth one, the article is not written in English, we exclude it. And the fifth one, article doesn't produce validated outcome. The last one, we exclude the paper or the articles which using multiprocessor based scheduling approach on edge computing and fog computing. So we focus on cloud computing and the research is generative algorithm. Next. We also have a quality assessment. This one, we have 5. The article must be supported by evidence. The second one, the rational and objective must be specific in details. The third one is outcomes and restriction must be specific. So it has to be clear. The fourth one, the GA parameters and scheduling function goals must be taken into account. So what is the goals, what is the parameters, we also search that one. And the fifth quality assessment is algorithm must be implemented on simulator or real cloud environment. So it's not only the hypothesis, it already implemented. Next. This one, after we use the key search, we have 385 papers. And we eliminate the redundancy and the one we have no full text, we eliminate and we have the 198. And then after using the inclusion and exclusion criteria, we have 67 papers. After using quality assessment, we down and then we only have 20 papers. The 20 papers we have IEEE Explore Conference 5 papers, IEEE Explore Journal 6, and then Science Fair Journal 9. So the total is 20 papers. We check those 20 papers on this parameter. Next. Can you see it here? No. So the first one is genetic algorithm based scheduling. In here, we see the parameter. As you can see, or you may understand, the genetic algorithm involves the population initialization, and then the second one is the fitness function, and then third one is selection crossover mutation. And then for objective function in low-pass scheduling, it involves the max time, execution time, cost, throughput, resource utilization, power consumption, load balancing, and trust or security. And the most left column is using, what is this using? So this one is the research question 2 is asking about the latest GA on the GA modified. So what is the modified one? This one is the selection, crossover, and mutation. So Xiong 2019 modified this function. And what is the objective function? It has this one. And how they modify it by using Johnson's and Rose's. So how you read this one is like that. So this is the citation code, and this is the parameter one, and this is the objective function. And what do they modify with? This is the rightmost is the what using modified using what. Okay, this is the research question 2 on GA modified. Next, and this is GA. So genetic algorithm is combined with what kind of different algorithm. This one we have 7. 1, 2, 3, 4, 7. So we have seven algorithm and modify with what? For example, here, PAM 2019, the modified is for fitness function and selection crossover annotation. Their objective function is the load balancing and what do they modify, hybrid, not modified, sorry. Combine with, they combine it with estimation of distribution algorithm. So in this one, if you read my paper, you already know what is the latest improvement on the genetic algorithm for low-class scheduling, and you can implement it in your hydro project. Okay, next. Okay, on the right, the widely used on the local scheduling is the using cloud sim, and then using the other one, and then the third one is using cloud sim plus. So I suggest you to using cloud sim because it's easy. Okay, and this is the publication distribution. So a lot of this published in 2021 and then 2022, and then the last one is 2023 because I put this paper on July, right? So it's only a half year. Next. This is our conclusion. Many researchers emulate plot scheduling challenge using the genetic algorithm. Although it's old algorithm, but it's still widely used because it's advantage. GL limitations are mitigated by combining them with other approach. GA is multi-objective algorithm that considers criteria, including maximum cost, throughput, and the others. This paper objectively examined GA-based scheduling strategies through research questions. This study followed SLR, systematic literature review, and Prisma criteria, and we checked 20 research among 385 publications. We classify and analyze GA-based algorithm into GA modification and GA hybrid based on the objective. And the last conclusion is the general performance of GA is quite excellent, but the complexity and opportunities to become traveled in local optima must be taken into account for more optimal task scheduling result. Okay, next. Yeah, this is fun. And then next. This is our reference. Last one. Yeah, you can contact us here.
Okay. Yeah, thank you for your clear presentation, Dr. Hani. And is there any question for you that joining online or offline about this? Basically, this is a works about the review of cloud. Anyone of you have a question? Yeah, please. Yeah, louder, please.
Okay, Andy, can you elaborate more, especially in previous slides that you mentioned about the load balancing objective function?
This one.
Yeah, about balancing objective function. How it can work in this load balancing? Because I know this algorithm need complex computation and take a lot of time to get the output. And as I know also about load balancing, so adapt fast to scale up to scale down, and yeah, how it works with task scheduling and your approach and the sync characteristic that should that fast as possible.
Yeah, you can directly answer it.
Okay. So, if we talk about task scheduling on the cloud environment, remember the cloud task scheduling is concerned about we have a lot of servers, right? And each server or each data server has their own virtual machine. Okay. So if we have say 100 virtual machines, and then we have 1,000 tasks. We have this one in the middle in the broker. Broker is their task or their job is to schedule the task. So the incoming task should be executed in which virtual machine, right? So which virtual machine is prepared load balancing. So not say 100 tasks is on the first virtual machine and then 700 tasks in the second virtual machine. It's not load balancing. So this objective function is to balancing the load between the virtual machine. That is one of the objective function. But sometimes say this one, you have cost and make spend. Sometimes, or the load balancing. Sometimes, one function objective is contradicted with the other function objective, right? Say you want to execute the task as fast as possible, right? We all want to do it, but if you want to execute it as fast as possible, you have to pay more, right? But in here, if you use the make, spend, and cost as your function objective, such as this one, so you have to find the balance between the first function objection and the second one. So how to do it? Using the algorithm, the optimization algorithm. And it also applied on the load balancing. So for the cloud service provider, I want to use this 5 virtual machine as equal as possible, right? Because I want to have this one as the first virtual machine is 200, say 200 tasks, and the second virtual machine is 200 tasks, and so on. But it may contradict with the function objective cost, for example. Or we use if we use the if we optimize the load balancing, but perhaps the max span is higher because it takes more time to execute it. So this load balancing is this objective function is to how to distribute the task on the virtual machine almost equally because we cannot reach the most optimal one of the task value. At least mirror using this algorithm.
Yes.
So it can connect with traffic. For example, this time just only hanya but some days then, for example, like we again, there are million client and access. So it's possible to use it because the complex computational knowledge
Yes. That's the disadvantage of JR. So if you use only the original JR, it's not good. So the recent research is it always combine the GA or modify the fitness function of GA, the mutation rate or the adaptation rate. We have to modify it because if you only use the original GA, it's not good. That's why I created this.
Okay, thank you for the presentation for the chapter number 5. For Dr. Ning, please applause to Dr. Ning. Okay, now we go to the next session. Unfortunately, I will be the presenter. So, there will be 2 papers. Yeah, I will be the next presenter because actually it's not my area. So, okay. So, yeah, even though I'm a better just if I have passed the time, right?
Yeah.
Okay, so can you make it full screen first? So yeah, this is sorry, my name is Bagus and this is the research about the vulnerability data assessment and management based on passive scanning method and CFSS. Actually, it's like we create an engine to track the traffic and also doing the vulnerability testing for a given website. Okay, so let's see the introduction first about understanding and ability to use vulnerability assessment. There is so many tools that we can use to check the security of the system, but of course, the price is quite expensive. Yeah. For example, have you heard about Acunetics? Acunetics is very pricey. Yeah, it's expensive and it requires certification to hold that one. And also the number of experts is quite small. And the second one is takes integration of automation scanning tools. We need a large quantities. It means that if we want to do a security test, we need a great numbers of workers to do the testing, and then mostly it's open source and it's created in various programming languages. So in this one, we want to build like an automatic system that they will do the security tests, but also they capture by doing the passive scanning. Okay, so now the problem definition becomes this four. The first one is how to design and implement the vulnerability assessment and management infrastructure by using the Docker container. And then the second one, how to manage multi-users in the scanning process. The third one, how are system resources used in the vulnerability assessment process. And the last one is how to find the vulnerabilities on a website based on the scanner that have been created. Yeah, basically this is some tools that we are using for this research. The first one is Nmap. The second one is OWASP. Yeah, we will use this one to do the testing scenario. And then we also using Sodan and PD and also the website of ICTS as the first one. But we also may test another website to do the security testing. So there is some reference of technology and terminology that we use in this paper. The first one, of course, the vulnerability assessment. We want to check whether there is a bug or there is a security vulnerability on current website or system. And then we also use this common vulnerability scoring system, or it's well known as CBSI2. Basically, it's a framework or scoring system to measure how secure are your system. So we are using this CBSI to do the scoring. The third one is OWASP or OWASP top 10. Yeah, basically they contain a lot of scenario how to do the security testing. And when the user submit the testing, we will conduct some security testing using the OWASP. And the fourth one, we use Docker container. So basically, if there is a one request and there is a vulnerability, the testing will be moved to the specific Docker container, and this Docker container will do the analyze the traffic. And then we are using the passive scanning. Passive scanning is different compared to the active scanning. Basically, if you're doing active scanning, when you are aggressively capture the traffic. But when we are using the passive scanning, actually, you only monitor the traffic that coming from the process. So this is the vulnerability assessment in general. The first one, you're doing the vulnerability identification. Normally, yeah, you will doing the vulnerability identification. And the second one, you will conduct the analysis, whether it's a vulnerability or it's just a false positive or false negative information. And the third one, you're doing the risk assessment. You will monitor the risk, whether it is high risk, medium risk, or low risk. And the last one, always we need to do the remediation to tackle the issue on the security. Yes, and also you may check the CVSS, or it's well known as the Common Vulnerability Scoring System. Basically, they provide a framework or like a scoreboard that you may measure the security of the system when you're doing the security testing. They separate the metrics into 8 parts. The first one is attack vector from the network, adjacent, local, and physical. The second one is attack complexity. can become low and high. And then the privilege required, you can do non-low and high. Also with the user interaction, the scope, the confidentiality, the integrity, and the last one is availability. Yeah, you may know this one, Triad CIA. This is the confidentiality, integrity, and availability. Okay, and for the security risk, we are using the OWASP. Yeah, we are utilize their scenario to doing the attacking from the injection, broken authentication, sensitive data exposure, XML external entities, broken access control, security misconfiguration, cross-site scripting, insecure serialization using component, and also insufficient logic and monitoring. So basically, we adopt their scenario, and we are doing the automatic website visit to do the automatic testing. And also, we will utilize Docker because Docker is highly portable, and we can give them chance to finish the analyzing the traffic. So what is the passive scanning? Actually, this is good for the vulnerability detection. And so user, we only take the minimum interaction, means there will be no disruption on the traffic. I mean, we will not disrupt the traffic still run, and we are not challenge and disrupt their traffic, but they may have also some false information for this one. Yeah, this is the system design basically. Basically, if you are a user, then you will submit your request to the CLI. Basically, if you want to, please check ICTS ICID. And then they will do the testing to the website, actually. They will do the automatic, for example, if we test the ICTS ICID, then they will do the traffic, thousands of visit and requests to the server using the OWASP scenario. And then for each traffic, they will capture the response and then put the Docker, and then they will process and analyze. And the result, they will store it in the database. So actually, we are creating the vulnerability detection system that based on the Docker and using OWASP scenario. So for the testing and evaluation here, the first scenario, the number of target is 100, and we are doing one process at a time. So yeah, because OWASP and CFSS has already is a major framework. So now we are targeting and how about the itself on the Docker. I mean, if we give them a huge number of process, how they can react to the requests. So this is the first one, as you see it in the container CPU usage. Yeah. When we are testing with ICTS ICID, so the Docker is the traffic, especially for the CPU usage, is not quite high. It's only 10% to 20%, and they can finish it in I forgot. In 9 hours. Yeah. Usually, if we do vulnerability test, it takes 6 to 12 hours. Yeah, and it takes 9 hours, and you can see that the CPU usage will not exceed until 20%. Yeah, no more than 20% for the CPU usage. And this one for the memory usage, okay, and this one is quite high. And also we conduct it in the same website, and it takes almost 7 hours here. And we can see that for the container memory usage, it takes almost 450 megabytes for the frequency. Okay, this is for the second scenario. Yes, this is for the second scenario also. We only doing this one process at a time. By doing one process at a time, we get a less usage. It normally, on average, it only takes 6%, but the optimal one is 10%. Compared to the previous one is 20% for 30 process at a time. But in this one, we only give 1% at a time, and it only takes 8 to 10% of the CPU usage to doing the analysis of the traffic. Also for the memory, if we only process it one at a time, maybe the if we can see here, the average is only 250 megabyte compared to the previous one, 480. And we can, of course, the difference is not quite far actually. Yeah. If we're doing one process at a time, it takes 250. But if we are doing 30 processes at a time, it almost half gigabyte. So basically for the conclusion, by using the Docker container, it's easy to deploy the engine to do the analytical tasks for the traffic, and it makes vulnerability assessment easier. And also for multi-user, we can use one container for one process or more. Yeah, and we also have already developed the task queue minutes for the scanning process. So basically, it is a cloud-based. If you want to make it cloud-based, you can do this, and they can perform the vulnerability testing for the machine. And also we also have the scenario selection for vulnerability assessment. So basically, we may provide the user for the customization. It means that not all of the scenario will be conducted. Maybe they can pick it half or all of the scenario. And for the system resources, actually, yeah, the task queue will maintain the number of process scanning in the system. And it means that if you have limited space for CPU and usage, so they will make a queue. Yeah, not all of them will executed together at the same time, but they will make a queue by themselves. Okay, so this is my presentation. Is there any question about this one? If you are interested in security for CTS and OWS. Okay. Oh yeah. How about the participant and online? Is there any question for you about this one? No question? Really? No question? So, okay. If there is no question, so let's move to another paper. Yeah. So, yeah, thank you for your attention. And this is for the security parts. We will discuss another one is for data engineering. Yeah, actually, the last paper that we will present in this parallel session is the paper about data engineering. So let's see. Okay, basically this is for not this paper is not about the security, but this is for from this cloud computing. Yeah, it's for infrastructure. So can you make it full screen? Oh, I think you should press the enable. Okay. Okay. So for this last presentation, it's about answering durable scalar query on multi-dimensional time series data using grid-based approach. So if you don't haven't heard about this one, the connection. Can you go back? Okay, so basically, the scalar queries is very specific queries. So if you are in the course database course, you are knowing about the MySQL, right? Structured query language. But actually, many of real cases, it cannot be solved by using database. So if you are rather being the data engineer, you may need your specific data structure to solve the specific problem. For example, if you are using Traveloka or Google Maps, how they can find a specific hotel that fulfills the preference. Actually, you need a specific database. So for example here, wait a moment. Okay, so like this query, give me hotel list with lowest price and highest rating review. Yeah, if you ask the system, give me hotel with the lowest price and highest rating review, it is a skyline algorithm. You cannot use the specific database, especially when they have a lot of criteria. Yeah, there is some specific query that you cannot solve it with database only SQL query. It's called data engineering. So for example, give me hotels with lowest price and highest rating review. Yeah, it's hard to do the rank if you are using the query standard query machine. Or if you ask them, give me the hotels with the lowest price and highest rating review from January to March. That's also a different question, and you cannot solve it very easily if you are using the common database, relational database system. So basically, this is the specific problem itself. It's called durable skyline query. Yeah. If you are previously, there is a teenager in the 19 and 2000. Yeah, in 2000, they were very likely to always listen to the music chart. You know, music chart, which song that being the top 10 in the 50% of this year. It's like which singer that may have been that was favorite at that time in 50% of this year. For example, like this one. Give me the hotels that have the lowest price and highest rating, at least 50% in duration between January to December. So you can become favorite from January to June, June to December, or maybe from February to July. Yeah. So you cannot solve this using the original RDBMS like Oracle, MySQL. You cannot solve this. For this specific, a data engineer will create their specific data structure for this purpose. It's called durable. This problem called durable skyline query. So yes, there is a lot of query like KNN, durable, and then another one. So for the goals, the first one, we need to design and implementing data structure and algorithm to answer time-based durable-based skyline query, and we need to implementing the optimal strategy to enhance it and how to understand the performance of data structures. Okay, so this is the question here. We want to ask in this paper. Actually, sorry. The durable skyline query selects time series data that is at least R% becoming skyline object within a time interval. So basically, you want to show and display which data that have been R% becoming the favorite during the time interval. Yeah. For example, you may ask them, hey, which dress mode that is being favorite at least 20% of this 20th century from this 20th century, you may find this good one, right? So basically, for this one, usually the scientists, they will create a specific database to support this one. You cannot use the regular RDBMS. In this one, we will create the data like a grid. Sorry, it's a limitation. And also, there's a dictionary event, and also we have a skyline box for the candidate. So basically, it's using a grid one. Yeah. Basically, we are doing the data pre-computing first to make it fast. So we will prepare the data and prepare the candidate here. And also, when the user asks, they will directly query processing and the return to the result. For example, if you are using Google Maps and you looking for give me the best 10 good restaurant here. If you are using RDBMS, it will take a lot of time because you are using the position and you are using the reference and others. It will take a time and you cannot use that RDBMS. You need to only take specific feature of RDBMS to answer your question. It means that you need to have a specific data structure and specific algorithm to solve that problem. In this one, we are using the grid computing and also using the skyline box here. Yes, yes, there's also an Indonesia economics. Yeah, basically they will do the event processing. Yeah, because the data will come and data will go, and then when the data come, we will insert to the grid, and then we will process the skyline first, And if the data removed, then we just remove those from this time. Like this one, yeah. We export the score box and then we create the data recomputing. Yeah, actually, this is what the Google do in the Google Maps. So they have prepared the answer actually, so you can get the answer in less than 1 second. But if you are using RTDNS, it will take maybe seconds or minutes. So actually, they have doing this computation like this one. They export the score box and then they have this timestamp table, for especially for this problem. And then when a people come and they asking 50% from this time interval 1 to 10, then you will give the output in less than 1 second. So yeah, in this one, the durable skyline is S1 and S2 because you asking, hey, which one the record that will be the best at least at 50% time in the time interval 1 to 10. So the answer is S1 and S2 because they are more than 5 seconds to be the best. And we compare it using this data, the independent, the anti-correlated in the forest cover. If you are interested with the data engineer, you know that this data is very hard to solve, the anti-correlated data, because almost all algorithms will fail to have a good performance when they are facing this one. Anti-correlated means you are good in what variable, but you are bad at other variable, like this one. Yeah, this is the specific data that is always have a huge number of computing time. And we are doing the testing, and this is the result. Yes, our algorithm, this is for the pre-computing. Yes, pre-computing takes 10 hours to solve this because pre-computing is, we are preparing the answer, but not the algorithm itself. Yeah, we just do the pre-computing time. And then this is the running time. Yes, this is the, sorry, this is still the pre-computing time. And this is the performance evaluation actually. Yeah, when we are doing this one, the performance evaluation, it takes only 60 milliseconds, less than 1 second. So user give the problem and then the system may answer it in less than 1 second. Yeah, exactly it's 65 milliseconds. And how about the number of data? When the number of data increase, also for this one is the memory usage. The memory usage will increase to almost 2 GB if you are using 200,000 data. But for this one, for the computing time, it's only takes no more than 65 milliseconds. And how about the effect of the dimension? Yeah, you see that in the 2 dimension, the time will be quite high. It's 95 milliseconds because if you are 2 dimension, it is less possible to dominate each other. Then everyone can be the answer for this one. But if you have more dimension, actually everyone can be the answer. So the time will be dropped here. And also this is for the memory usage. And this is for the running time for memory, running time and memory for interval query. Yeah, the longer the time, you see here, the computer time will be dropped because everyone can be the answer if you have more time. Yeah. If you're asking them and you give them more space, it is highly possible that all of the record will be the answers, right? So in this one, the computer time is dropped, and for this time, the memory still same. There is no change for the memory usage. So for the conclusion, we have designed and implement. We have designed and implement for the durable scanning query, and then the second one we have implemented it, and we get that the result is quite good because we can answer it in less than 1 second. And the performance, they will have a problem when they face the huge number of dimensions. Okay, I think this is the last of the presentation. Is there any question from you about this data engineering stuff? Oh yeah, do you have a question, please?
Okay, correct me if I'm wrong.
Yeah.
So is approach working on static data set?
Yes, it's for historical data set.
Yes. According to it's possible to use approach in
Stream like a real time, right?
Yeah.
Yeah.
Because we're working timeless.
Yeah, I have already published the previous paper. It's about the stream data. it's a real time because one people come and one people go. But for this one, because you are asking how many people that ask 50% is in the previous time, right? In that case, you cannot use the string because the problem itself is talk about the historical part, right? Because if you talk about how many percent in this duration time, means you're asking for the previous time, right? So you cannot use this string. But there's also durable scalar query is for historical, but for scalar query itself, it talks about the current data. Yes, and it takes another strategy. Yeah. Of course, you can do pre-computing, but to monitor only the position. Like yourself, if you are here and you get a list of restaurant in your project maybe, and you are going to another place, you will get the different result, right? Actually, Google has already case doing the pre-computation first. Okay, not do the project, has doing the pre-computation and then answer. So actually, it depends on the situation. If you are using durable, so it means historical time. If the real time is not, yeah, not a problem. Okay, is there any question from you or others? Okay, I think this is the session, the end of our session. Okay, so yeah, thank you again for all of the authors. So now I'm becoming very clear. So yeah, thank you. Thank you for all of the moderators here. So for all of the presenters here, we have already listened for the 7 presentation from the first one, the evaluative analysis on low exponent, until the last one is about answering durable scalar query. So again, thank you for your participation and presentation for all of the authors from the paper number 107, and also thank you for your coming, all of the participants here. And hopefully we can meet in the next ICTS in the 2024. Okay, thank you, see you, and goodbye. Thank you.
Okay, for all participants, please wait a moment. Goodbye. Yeah.
Okay.